great and terrible. Compressed air is everywhere in the industrial world. It's often called fourth utility, but it has a serious fundamental problem. Please welcome Steve.
I brought my small air compressor with me today. Of course, compressed air systems vary dramatically in size. You'd have a little hand-powered one. You might have a 2 horsepower compressor at home you use for driving nails or for construction, something like that. A machine shop might have a 50 horse air compressor. You go to a big paper mill, they might have 4, 5, even 10,000 horsepower worth of air compressors that run all the time. Compressed air, and the reason is because compressed air is really great. It is super versatile. Once you have compressed air in a hose, in a pipe, you can use it to push, pull, carry, cool. It can stir things, it can dry things. And when you're done with the compressed air, it just disappears because it's air. We just got it from the air, we compressed it, we used it, and then we just put it back in the air. So very clean to use. In fact, 7 out of 10 industrial sites in America have air compressors, and 10% of the electricity generated in the United States goes to an air compressor. So you see all those wires outside? 1 in 10 pieces of that electricity is going to an air compressor somewhere, which is a stunningly big fraction. But it's also really terrible. And let's do a little thought experiment, and let's see if we can understand why compressed air is terrible. Okay, everybody grab a gallon of air in front of you. You have a gallon? Okay, now imagine yourself crushing that gallon down to the size of a pint. That's an 8-to-1 compression, which would give you about 100 psi of compressed air in your pint. Now, if you could do this without any heat escaping, what temperature do you think your pint of air would be? Any guesses? 600? Any 300 degrees Fahrenheit? Any other? Well, you're very close. Your pint of air would be 500 degrees Fahrenheit if you compressed 8-to-1 and got 100 psi. But why aren't 500 degrees Fahrenheit? And the pipes in the factories are not all 500 degrees Fahrenheit because we've thrown away all the heat of compression. We end up with this waste heat that we have oil coolers and intercoolers and aftercoolers on the compressed air systems, and their only job is to take this heat and throw it away. In fact, 85% of the power that you put into an air compressor turns into heat, which we usually can't use, so we just throw it away. We use it to evaporate some water or heat some air in the atmosphere. If I was to need to do 15 horsepower worth of work on a shop floor, and I was to do it with a compressed air powered piece of equipment, I would have to run a 100 horse compressor, and it would cost me $50,000 a year to buy the electricity for that compressor. Now, if I could just do that directly with an electric motor, it would only cost about $7,000 a year. And so there's that difference. There's all that waste heat that we throw away because of the nature of compressing air, because air is so compressible. So what are some things we can do to get the most out of compressed air and to use it efficiently? Well, one, as you can probably guess, is let's not use it unless we need it. It's really cool. There are some applications where it's super useful. If you're like in a wet or an explosive environment where you don't want to be running electricity, compressed air can be great there. But if you're in some other environment and we're just pumping some chemicals around, well, let's just use an electric pump if we can do that instead of a compressed air powered pump. Another way to reduce the load would be leaks. Studies show that on average 30% of all of the compressed air that's made just gets leaked. So if you find leaks in your compressed air system, get right on them. I've been to plants where they tell me, well, they pay us to make these widgets. They don't pay us to fix compressed air leaks, but they're leaking $50,000, $80,000 worth of compressed air every year. So it could pay to fix those leaks. Another principle would be to turn it off. A lot of times compressed air systems are left on nights and weekends, and there's no one there, and so really all we're doing is just feeding leaks. So if we can shut the system down, that will save energy. Right sizing our equipment is also key to a system's performance. Often people will get used compressors or used compressed air dryers on a fire sale off the back of a truck. It came out of some factory and they're just looking to unload it. You know, here's a $80,000 air compressor and you can have it for $2,000. Yes, I'll take it. Look at that. That's great. Now I have this 75 horse air compressor, but I only need like 15 horsepower worth of air. So my compressor is way too big and it's going to be very, very inefficient because compressed air equipment does not operate efficiently at low load. So use the right size of equipment for the job. One last principle is remove barriers to more efficient set points. Some people say, well, I need to have 140 psi compressed air because this piece of equipment won't operate properly if I lower that. But there may be filters or regulators or piping issues that's causing this piece of equipment to require the higher air pressure. If we can go solve that problem, we can turn the whole plant air pressure down and save a whole bunch of electricity and a bunch of power. So compressed